Now, I will do a couple of these graph questions. E and F, was it? No, seriously, we need to be considerate of time here. I can't do three. I will try to do E, F, and G, but if it's taking too long, I'll stop at E and F, okay? Now, I'll tell you now, take out your calculator rather than me waiting later. You got it? Okay. So, E firstly. Now, are we ready? Because I'm going to... Are we ready? Because I'm going to go through them quickly, okay? So, firstly, we'll find the A. If you look at this graph in E, what's the maximum? The maximum in E is 2. And what's the minimum? -2. Yes? So, how high is this graph? 4 units. But normally, what should the height be? 2 units. So therefore, how many times bigger is it? 2. Twice as big. No talking. You need to really focus because I'm not going to go slow on this. Okay. Are we all happy with how I got the A? Right. The next one is the D. What is the maximum and minimum here? Well, it's at 2 and -2. Yes? And what do you expect it to be at? 2 and -2. So it's not being raised or lowered. So therefore, D equals 0. Good. Okay. Now, when we look at the inside, which one do I do first, the B or the C? C, wasn't it? That's what I did last time. The C first, yeah? No, what are you talking about? The B. Who said C? Yeah. B first. Now, if I look at this graph, there's a little formula I gave you last time if you want to calculate the B. What did I say it was? It's 2 pi over the length, or the period. Yeah, n minus start. Okay, that's one way to calculate the length. But another way to calculate the length is not just n minus start, but also the distance between the peaks or the distance between the troughs. So if I look at E, I can see that, for example, there is a trough. You know what I mean by trough? It's the opposite of peak. You can see how it's at pi over 6, yes? Is that right? And then you can see where's the peak is at 7 pi over 6. Now remember, I said from peak to trough, but how this is trough to, I said peak to peak or trough to trough. This one is trough to peak, which means it's only half the length. So pi over 6 to 7 pi over 6. If you just minus them on your calculator, tell me what you get. You get pi. Yes?
Isn't it supposed to be pi over 6 minus?
No, it's 7 pi over 6 minus pi over 6. I'm looking at the 2 at the right. Now, how big is that? Pi. But that's
only half.
Well, you can't take 2 peaks only because I can see that this peak is at 7 pi over 6, but I don't think the other one's at minus 7 pi over 6. It's not clear on the graph. I'm not confident in saying that the other one is minus 7 pi over 6. It looks like it's a little bit off center. Yes?
And when did we divide by 2?
When did we divide by 2? That's when we wanted to take the middle of 2 numbers. Not something I need to do here. Right, so you all got pi in your calculator, but that's for half a length. So how much is 1 full length? 2 pi. And how much do you expect it to be? 2 pi. But that doesn't matter, because if I just put into my formula, 2 pi over 2 pi equals 1.
Why did you put 2 pi?
2 pi is what we said the length is.
Oh.
Yes? Yes?
Do you remember the formula that you gave us?
This is half a period.
Yeah, there's half a period, yeah.
Do you remember the formula that you gave us? It's 2 pi over n minus 1.
Yeah.
But the astronaut was that to me as 3 over 2.
But you can't see what the start and end is here.
I'm talking about the volume.
Right? If you look at this graph. Can everybody, no talking, no talking, no talking. No talking. Everybody look at graph E. You can't clearly see where the start and end is. The only points listed here are the peaks and the troughs, maybe. So, as Hassan was saying, when I looked at from trough to peak, I was looking at half the period. I just doubled that answer to get 1 period. Yes? Right. Now, how do I find the C? By putting in a point. And I think I put in the point, you see at the end there, 7 pi over 6. What's the Y for that value?
2.
Yeah, so 7 pi over 6 equals A, B, which is 1, C, and D is 0. Okay, somebody tell me what the C is here. Thank you, I did it again, didn't I? Wait. I did it again. Thanks. The Y is 2, and the X is 7 pi over 6. Okay. Now tell me what you get. Well, 2 divided by 2 is 1. Sine inverse 1 is pi over 2. Pi over 2 minus 7 pi over 6. Pi over 2 is 3 pi over 6 minus pi over 6? Minus pi over 6? You're in radian mode, right?
Yes.
Minus 2/3 pi, thank you, okay.
How did you get the coordinates again?
I just picked the point on the graph, and the easiest one was the one at the end. The 7 pi over 6, yeah. Yes? Is silence good or bad? I don't know right now. It's good? Alright. I'm going to do F now, so write down what you need to from this. Got it? Okay. F now. So let's try and do it by just looking at it directly. So what's the height in F?
0.
No.
F. 3. Minus
2. 2 is the height. It's too high, isn't it?
Yeah.
Yes. And what do you expect the height of a cosine graph to be? 2. So therefore A equals 1. Now,
Shouldn't the height be?
wait. Sarah was trying to ask me something. Go ahead. All right.
That's 4.
All right. Let's be cool. Everybody, look at F.
Oh, F. Yeah. That's not my big.
Everybody, look at F.
Yeah. 2.
You see that the graph goes from minus 2 to 0. Yes.
Yeah.
So that means it is 2 units high.
Yeah.
A cosine graph is normally how high? 2 units. So has it been increased or decreased? It has not. So A is 1. It's like you multiply by 1. Right, now we're happy, yes? Right, now, if I have a cosine graph, a 1 cosine graph, what is the minimum and maximum normally?
Minus 1 to 1.
Minus 1 to 1. Whereas this one is what?
Minus 2 to minus.
Minus 2 to 0. So has it been raised up or raised down?
Minus down.
Raised down by how much?
Minus 1.
By a unit, by 1 unit. So D here equals
Minus 1.
minus 1. Now time to get the B by using our formula. 2 pi over the length. Now if I look at this, I can see, can you look here? at minus 7 pi over 8, what do you have? You have a trough, don't you? And then if you look at pi over 8, what do you got there? A trough. So the length would be from trough to trough. So pi over 8 minus 7 pi over 8 is pi. So the length is pi, so 2 pi over pi, 2. So that's the b. Finally we get the d, and I will use the point on the far left for d. So I'll say y equals minus 2 equals a cos b x plus c plus d. Okay, so tell me what the c is here, please. So you do minus 2 plus 1 is minus 1 divided by 1 is minus 1. Cos inverse minus 1 is 3 pi over 2. 3 pi over 2 plus 7 pi over 8. 3 pi over 2, that's 12. 7, oh, I lost at the end. Come on, you all have calculators, don't just look at me. So tell me what the c is here. It's going to be 3 pi over 2 plus 7 pi over 8. Or times 3, 12, 12 plus 7. Is it 19 pi over 8? No, here it's... Oh, the 2 in front there, thank you, yeah. Did you get an answer for C? Oh, come on. What is it? 3 pi over 4. Did you get that also? Are you sure? Yes?
The answers you solved here are different from what I got. And what I got is exactly the same as the back.
Good for you. But like I said, there's infinite number of answers. I think the two that should always be the same is the A and the B. The B and the C can change though. And the reason the B and the C can change is because with these cosine equations you have multiple answers. If your A and D is right, then it means you've probably done your B and C right also. Yes? So it's all cool. All cool. Hey, listen. Notice how I chose the point at the far left, yes? If you choose another point, you will get a different answer for C. Yes.
Will our answer stay the same with the 2 pi over start minus 7?
The answer stay the same at the back?
No.
Don't know what you're asking me, but you're worried about something that isn't a problem. It doesn't matter that the answer's different, because there's multiple answers.
No. I'm not worried about the answer. I'm worried about the formula. What is the exact formula? It's 2 pi over n minus start?
It's 2 pi over n minus start, or if you prefer, it's 2 pi over the length, which is n minus start. Or, what's another way to get the length? Peak minus peak, or trough minus trough. Or you could do...
Same meaning.
Yeah. I'm not sure what the problem is here. The formula for B is 2 pi over length, yes? And length can be found by doing what? N minus start, or peak minus peak, or trough minus trough. Or you could do peak to trough and double your answer. Right? Moving on. I need to go to a new page. Yes? Yes. Right, finally now G. Alright. What's the height in G? Are you sure? You sure? 3. And how high should a cosine graph normally be? 2. So how many times bigger is it? 3 over 2. Oh, it says... Alright. So there's a problem with that one. So chill. It's all cool. 0 to 3. So A is 3 over 2. Now,
What is
You just
right, how high is cosine normally? 2. And how high is this graph?
3.
And how can I go from 2 to 3? By multiplying by 1.5. And 1.5 equals 3 over 2.
Just divide both of them. Aren't we looking at how many units?
No, we're just looking how many times bigger it is. Yeah? Right. That's the A. Okay. If A is 3 over 2, what should the min and max be for cosine? It should go from minus 3 over 2 to plus 3 over 2. Whereas this one goes from 0 to 3 over 2. So it's been raised up. How many units?
Plus 3 over 2.
Correct. 3 over 2 units raised up. Now, I need to get the B. Let's have a look here. I can do trough to trough. If you look here, minus pi over 4 to 7 pi over 4, that is 2 pi units long. Yes? So what's the B here? 1. Come on, focus. What's the formula for B? Now look up. Everybody look up. Be looking at me. Down the back too. What's the formula for B? 2 pi over the length. And what's the length of this graph here? Trough to trough. It's minus pi over 4 to 7 pi over 4. If you minus the 2, you should get 2 pi, right? So B is 2 pi over 2 pi, which is 1. Not minus 1, not 2 pi, 1. Okay? Now, finally I need to get the C. Which point will I use? Anyone you like. Well, not anyone. Which one can I use? There's only 2 I can really use. Minus pi over 4 looks good. So 0 equals A cos B, which is 1, x, which is minus pi over 4, plus C plus D. Well, I can cancel those actually. And I get 3 over 2 pi plus pi over 4 equals C. So that's 7 over 4? No, sorry. No. I can't do this without a calculator. How do I cancel the 3 over 2? I divide everything by 3 over 2. So I'm left with this. 0 equals cos minus pi over 4 plus C plus 1. Now if I take the 1 over here, I get minus 1 equals cos pi over 4 plus C. If I do my cos inverse, I get 3 over 2 pi equals minus pi over 4 plus C. And like I said earlier, 3 over 2 pi plus pi over 4 equals C. This is 7 over 4 pi, right? Look, I don't have a calculator. You have a calculator. Check if that's right. Did you check that that's right, Ahmed? Get checking. Cos inverse minus 1 is 3 pi over 2, isn't it? Isn't it? Cos inverse minus 1 in radian mode. It's pi. Well, thank you. Right, so pi. Yes. All right, so that fixes that. That should be a 5. Yes? Yes. Now, we can check that this is right if you want by plotting it in Derive. You all know how to do graphs in Derive, so if you want, you can check this way too. Did you write that down if you need to? Yes? Go up. Well, it's just to here, really.
Why did you put the y equals 0?
Because if you look at the graph, I chose the point, Sadiq, be quiet. I chose the point minus pi over 4, 0 on the graph to put in. You all see on the graph that the graph touches the axis at minus pi over 4, yes? So what's the height at that point if it's touching the axis? It's 0. So, x is minus pi over 4, y is 0. Yes? Right, can I leave this now? Yes? Right. Now, if we look at the next page, 75, is there questions from this one? You sure? Because number 3 is the same as number 2. So, the only difference in number 3 is you don't need to find the c, just the m. Any questions in page 75? No? Moving on? Please stop talking. I'm waiting for you to stop talking. What's the question? In which one? Okay. You got 2 answers. You should only have 1. And you got 2, yeah? But one of them is the answer at the back. So, let's see what happened there in that one, actually. Okay, so I'll just do 3y from this. Y equals minus 9x squared minus x minus 2. And I have my tangent line y equals mx plus c. And they meet at one point, so therefore I can solve them. Mx plus c equals minus 9x squared minus x minus 2. So I get minus 9x squared minus x minus mx minus 2 minus c. Well, multiply everything by minus. 9x squared plus 1 plus m x. Sorry? Why did it take so long to spot that? Alright, y equals minus 2x squared plus x minus 1. Y equals mx plus c. So I have minus 2x squared plus x minus 1 equals mx plus c. So if I take everything to the right, I get 2x squared plus mx minus x plus c plus 1 equals 0. So 2x squared plus m minus 1x plus c plus 1 equals 0. Now, because this touches the quadratic at one place and one place only, what should the discriminant be? Should be 0. So you get b squared minus 4ac should equal 0. So you get m squared minus 2m plus 1 minus 8c minus 8 equals 0. Okay. Oh yeah, well I can clean that up a little bit more. M squared minus 2m 1 minus 8, so plus 7 minus 8c. Thank you. Equals 0. Now I haven't found the c yet. I need to know what the c is too. If I go back up to the top here, I tell you where they meet. Where do they meet? I say it in the question. X equals 0, yeah? So that means if I put x equal to 0 into both of these, then that's a solution. That's where they meet. They meet at x equals 0. So if I put x equals 0, let's see what I get. What do I get for the first equation? Y equals minus 1. And here, y equals c. This is at x equals 0. So therefore, what does c equal?
Why did you change the A to plus?
Because c is minus 1. No, it's only one answer. Where was your slip that made the two answers? Sign error, maybe? Oh, you were way off. I think you were just lucky that one of the answers turned out to be the one at the back. Okay, so now let me tell you some good news. In question 2 and 3, you had to use the discriminant to find the tangent line, yes? And you don't need to know this for the exam. There's actually a better way to do it. That was the reaction I was looking for. There's a better way to find the tangent line. I had to do this because it's on the syllabus. But there's two ways to do it. Just like with solving system of equations, there's multiple ways to do it. This is not the way you would do it for the exam. So if you found it difficult, which I think you actually didn't, it's all right. Next page, 77. So. Okay. So. Here's the situation. If I give you a quadratic, you know how to find tangent line to it, right? But if I give you a cubic, you don't actually know how to find the tangent line. Why not? What's different about these two situations that lets you find it here, but not here? No? Well, tell me this. What formula did you use to help you find the tangent line in the quadratic? What did we use? Discriminant. And does discriminant work for cubic? No, it's only for quadratic. So we need a new way, a new technique to find slope of tangent lines that works for every graph. And that's what we're going to look at now. Okay. So you don't need to write that. So here is the idea. Here's the formula. So there is my graph. Maybe it's something like a cubic. I'm not sure. Whatever it is. I'll draw that again. Okay, there it is there. Now suppose I want to find, let's say, the tangent point here at xy. Any ideas of what we could do? Well, if I just roughly draw the line in, I could try and get it from a graph, but this isn't really accurate. If you want to find the slope of this line, how many points do you need? You need 2 points, right? Now the problem is you only have 1 point. So what we do is we pick another point on the curve that's nearby and then join these 2 points. Now notice how it's not exactly the same, but it's close, right? But it's not exactly the same. So if I call this first point xy, what I'll do is I'll move a little bit to the right and call the second point x plus h, and if I call this one y1, then this one here be y2. So what I've done here is, I know this point, I need a second point to find the slope, so I'll move a little bit to the right and take another point on the curve and use that one. It won't be perfect, but it'll be pretty close. Right, and let's call this curve fx. Alright, so using our regular formula for slope, what's the formula for slope? y2 minus y1 over x2 minus x1, which here will be y2 minus y1 over x plus h minus x. There's x2, there's x1. Now what happens here in the denominator? X cancels. Now I need to find what the y's are. How could I find out what the y's are if I knew the x's? I could put them into this formula, couldn't I? So instead of y1, I could have y1 equals fx1 and y2 equals fx2. So this becomes fx2, what's x2 here? X plus h minus fx all over h. So this is called the first principles formula for calculating the slope of a tangent. So I'll summarize, I'll put in a box here for you. So the slope is approximately, the slope at x is approximately f of x plus h minus f of x all over h. So you definitely need to write that part down. Yes? Go scroll up. Okay. Okay. There's a symbol that represents slope of tangent, and the symbol for slope of tangent is this. So when we talk about slope of tangent, we could use the letter m, although this symbol here is used, which we'll see why later. So delta y over delta x means slope of tangent. So we'll have a look at an example now. So example, find the slope of the tangent to y equals x cubed at x equals 1. So this is very similar to question 3 of the last class, except it's cubic now, whereas the last one was quadratic. Are we ready to see this, or do you need a minute? Need a minute? Okay, since people are starting to look out the window, I think I'm ready to do this one now. Okay, so using our formula, delta y delta x equals f of x plus h minus f of x all over h. So what's the function here? It's x cubed. So I put x plus h into x cubed, and what do I get? Anyone? So if I put x plus h into this, what do I get? I get x plus h cubed minus f of x. What's f of x here? X cubed all over h. Now, have you seen this problem before? X plus h cubed. Yes? So we can use Pascal's triangle or whatever we like. Remember? So the answer here would be x cubed plus 3x squared h plus 3x h squared plus h cubed minus x cubed over h. Now, what happens to the x cubes? Cancel. And notice how there's a h in everything, and I'm dividing by h. So I can cancel this with this, and I can cancel it with a power, and I can cancel with a power here to make that 2. So I'm left with 3x squared plus 3xh plus h squared. Although I'm not finished yet, what did I tell you the x was? I said it was 1. So I get 3 plus 3h plus h squared.
So, why don't you cancel the second h completely?
Why didn't I do what now?
Like, why don't you cancel the h completely? Yeah, so
Which h completely?
like there are two, h squared and h cubed.
H divided by h?
You know, in the second,
No, I'm getting to it. H divided by h? 1. H squared divided by h? And h cubed divided by h? H squared. Yeah. That's the answer. Now notice how there's h in my answer. But what does h represent? If we think back to my proof earlier, the distance between the 2 points. Okay, so now I'm going to go on to question 2, but it continues from question 1. So let me just go down a little bit. Delta y delta x is approximately the slope. But who can tell me how they think they can find the exact value of the slope? What should I do with h? Make, yeah? No? Yeah, y0.
it's very small.
So look here. You have your 2 points, yes? And they're separated by a distance h. But if a tangent touches the curve, how many points should it meet at? 1 point. So how can you make 2 points into 1 point? By making the distance between them 0. And what letter represents the distance between them? H. So if you want to find the exact answer, all you need to do is put h equals 0. And if I put h equals 0, what do I get? 3. And this is the exact value for the slope of the tangent, and the symbol that represents the exact value is dy dx. Have some people seen this symbol before? And now you know exactly what it means. Okay? So this is called the first derivative.
There's another name for it.
We just go with derivative.
Do we have to do
Or
all of
mishtaka
those
in Arabic. Yes?
We have to do all of those steps.
If they ask you for the first derivative by first principles. What's the name of this lesson? First principles. And if they ask for the derivative by first principles, you have to do it this way. Brendan.
So this is just like the proof. I'm figuring out the kind of derivative. They don't normally ask for proofs, do they?
How many IFI exams have you done?
Okay.
That's right. In fairness though, Brendan, it doesn't come up often. I would say this might come up once per 5 years.
Did it come last year?
No.
Okay, it's coming this year.
And the reason I say once per 5 years is because it hasn't come in the last 5 years. Although it has come up before. So it is due. It is likely to happen soon. Huh? This question is likely to happen soon in the exam. Okay? So that's all you need for the first lesson. You need the form. Hey, listen, no talking. For the first lesson, you need 2 pieces of information. Firstly, This formula calculates the slope approximately. And then if you want the slope exactly, what you do is you first calculate it approximately, and then you make h go to 0 at the end. And this gives you the exact value. Okay. Now I want to show you something in Derive. I'll go back to the screen in a minute. Look. So what I'll do is I'll make the function x cubed, wasn't it? Yeah. Right, look. So here I have fx. If I have to, again, stop because someone's talking, I'll just ask you to leave. I'm getting tired now. Fx equals x cubed. So what was our formula for the slope? It's f of x plus h minus f of x all over h. Simplify this. And that's the one I got earlier. And then I can make x equal to 1. But I want to graph this now. So if I just put a graph of this, y equals f of x. Right, let me zoom in. Too far. It was fine at the start. Right, now I'm going to draw the tangent line here. I think Derive can do tangent lines. Oh, anyways, no, I'll just zoom in actually. Center on cross, zoom in. Alright, there is x equals 1. So what you need to imagine, what happened here is I put a point, xy, and then very close beside it I put another point, which was only a tiny bit moved to the right. I'll call it y2. Now if I draw a line joining these two, it's not quite a tangent because it cuts it at two places. But as h goes to 0, you can imagine this point sliding down towards this point. And when h equals 0, the 2 points meet. And if I draw a line through that point, I got a tangent because it's only meeting at the curve once. Okay? So when you put h equals 0 at the end, that is why you get the exact answer, because you're changing it from a chord, remember chord, to a tangent. How many places does it meet if it's a chord? Twice, tangent once. Okay? Right. So you can start the questions now, but what you could do is the first two and the last two in each. First two and last two in each.